Hello everyone. Today, I'm going to show you how to get started with MicroPython on an STM32 board. I'll be using the STM32F4 Discovery board for this demonstration. Let's get started. First, connect the ST-Link and USB user ports to your PC using the appropriate cables. Then, open STM32Q programmer and connect to the development board using ST-Link. Next, we need to erase the MCU's flash memory. Click Erase Flash Memory, and then select Full Chip Erase. Wait until the erase process is complete. Now we need to download the MicroPython firmware for our specific board. Go to the MicroPython website and click on the download section. Select your board, in my case, the STM32F4 Discovery. To install the firmware using ST-Link, we need a .hex or .bin file. Click the .hex link to download the latest release. Once downloaded, return to STM32Q programmer, open the .hex file, and click download to flash it to the board. You should see a message saying the download is complete. Now disconnect the ST-Link. We no longer need it for debugging. You can close STM32Q programmer. MicroPython is now running on the STM32 chip. Next, let me show you the device manager. At this point, you'll only see the ST-Link COM port. To activate MicroPython serial COM port, we need to reset the board. Before reset, let me show you the File Explorer. Press the black reset button. You should see a new COM port appear. This is the USB user port. If we look the File Explorer now, you can see the new flash drive PYB flash appeared. If you open the drive, you can see there are 4 files. The first one is boot.py, which is going to run at boot time. Main.py is the second file, where we write our code. The next file is a driver file. If you're running Windows 7 or lower, you need to load this driver to enable the MicroPython Serial Interactive Console. If you are using Windows 10 or 11, no need to load this driver. If we go to the README file, actually tells you how to do that. If your new COM port has the same number as the ST-Link port, you'll need to change it. Right-click the port properties, port settings advanced, and assign a different COM number. Then press reset push button again. Now, let's open the MicroPython serial console. You'll need a terminal program. I'm using Tera Term. Open the USB user COM port. Once connected, you'll see the MicroPython interactive console. Let's quickly adjust the terminal font size. We can do some testing on the prompt. 2 plus 2 is equal to 4. 5 divided by 2. You'll get 2.5, notice it handles floating point values. Now let's control the onboard LEDs. pyb.led1.on and hit enter. It will turn on LED 1 on the board. Then turn it off. Try the same with LED 2. Next, let's test a loop. You'll see both LEDs toggle in a loop. Now let's move this logic into the main.py. Open both boot.py and main.py. First, uncomment the line in boot.py that loads main.py. Now in main.py, add your custom code. I am going to add the lines to blink the LEDs in the while loop. Now in main.py, add your custom code. I am going to add the lines to blink the LEDs in the while loop. Save both files. Before reset, wait around 6 seconds to ensure the file is saved properly. You should see LED 1 turn on briefly and then turn off. Once it turns off, press the reset button. The blinking LEDs should now run continuously. Perfect. Now, let's move on to external interrupts using a push button. Open the serial console again and type help. You'll see extension int, the external interrupt object. To understand how to use it, check the MicroPython documentation. There are steps on how to configure that. First, we need a callback function to call when an interrupt occurs. Now let's initialize the interrupt mode. Copy the code from the description and let's edit it. First parameter is the pin. Let's create a new variable called pin, and it's equal to pyb pin.cpu.a0. In my case, the blue push button is connected to the A0 pin. Then in the second parameter is the mode of the trigger. It's okay with the falling edge. The third is the pull condition. Set it to none since we're not using internal pull resistors. The last is the callback function. Finally, we can enable or disable the external interrupt. I'll also turn LED 1 on and LED 2 off. I'll also set LED 1 on and LED 2 off. Save the file, wait a few seconds, then press the reset button. You can see there are no errors in the code. If there are any errors, they'll appear in the serial console. Now, press the button. You should see line equals 0. This indicates the interrupt was triggered by pin line 0. Let's improve it by toggling LEDs on button press. Update your callback function to toggle the two LEDs. Save the file, wait a bit, then reboot. Now when you press the button, LEDs toggle correctly. And that wraps up today's tutorial. We flashed MicroPython to an STM32 board, ran code interactively, and used external interrupts to trigger behavior. Thanks for watching, see you in the next one.